I'm Brad. I work at Google on the Go team for 8 years or so now, and I'm going to talk about Go 1.11 and beyond. So that's kind of, I'm using the new slide template here. It's the first time. First, Go 1.11. The release cycle, if you haven't noticed, every 6 months we do a release. We've been doing this for a while now, and we have like 3 months of kind of crazy development and 3 months of stabilization. So we should, in theory, have a release out on Wednesday for Go 1.11, but as we often do, we're running a little late, so it may be, I don't know, like a week late or something. But it's basically done and frozen, and we're using it inside Google now. You can go read the release notes to see all the good stuff in Go 1.11. It's kind of long. We will be reading through this today. So you could read this and find all the good stuff, or you could just go to Hacker News and ask if the language has generics yet. You can go back to the release notes and see there are no changes to the language specification. Then you go on Hacker News and complain about that. This is their least favorite part of the release notes. So let me teleport back to 2016. About 2.5 years ago, I gave a talk at GopherCon India introducing Go 1.6, and the talk was subtitled "Asymptotically Approaching Boring." And I had this really scientific graph about the number of language changes per release from Go 1 to 1.1, 1.2, 1.6. And it's kind of going down, and I showed that all the excitement was before Go 1, before 2012. And so if you're a language nerd, that this is really boring, but boring is exciting if you like stability and you like building stuff on top. And Go, when you say Go, that's not really the language specification itself. There's a whole ecosystem on top, and the standard library is kind of frozen. The runtime's very exciting. There's excitement in tools. The ecosystem is exciting. So now we kind of come back to today. And Go 1.11 is basically 1.6. It's still kind of boring, but there's a lot of changes, and we're going to just focus on some of these. This is the table of contents. Jana already talked about trace. We don't have much time, so we'll focus on a few of these. So first off, ports. We have this section of the release notes where we talk about things that are specific to certain operating systems or architectures. And there's a lot of boring stuff in here, build mode C shared now works on FreeBSD, AMD64, or you can now use the race detector on PowerPC 64, Little Endian Linux, and blah, blah, blah. But there are some exciting parts, at least to me. Go 1.11 now requires macOS 10.10 or Windows 7 or later. And I'm excited about this because it means Windows XP support is dead, and we don't have to test that anymore. So I'm sorry if you use Windows XP. We supported it much longer than Microsoft did. So, also exciting, we now support WebAssembly, and there's now an experimental syscall/JS package for interacting with the host that's running WebAssembly, which typically will be JavaScript. If you've been living under a rock or living under server-side programming, there's this thing called WebAssembly out, which is you can think of it like Flash or Applets or ActiveX or Pinnacle or Native Client or whatever, except for all the browsers actually care and implement it, and the whole process was done correctly through standards and people agreeing, rather than just trying to take over the web platform. So it's a very webby thing, and everyone likes it and agrees on it. But it was kind of designed for languages like C, C++, Rust, and this affects us a little bit in that it's not a straightforward architecture to target from Go. So kind of as a result, the hello world binary is about 2 megabytes, and that's 2 megabytes you're loading into a browser. It's 500 kilobytes when you compress it though, so it's not terrible, and in theory it's cached, and sometimes you have images that are that big anyway, so maybe who cares. But there's definitely room for improvement, which I'll talk about. Right now you compile Go into one big old thing. You can call from JavaScript to Go. You can call from Go back to JavaScript and manipulate the DOM and stuff. You don't really have to write any JavaScript at all. We give you this one little glue with a few lines that loads the module and kickstarts it. There are higher level packages to do all kind of the DOM manipulation and virtual DOM sort of React sort of things if you want. And so the syscall.js package that's included now in the standard library is not really intended for most people to use. It's kind of like Reflect is. It has to be there, but you don't really want to use it. There's a bunch of stuff in development that will make web development fun in Go. You can't yet compile your program into different WebAssembly modules, which WebAssembly supports. So ideally, you would have like the runtime in its own cacheable unit, so browsers don't have to re-download the Go runtime with channels and garbage collector and stuff every time you hit a site using Go WebAssembly. But right now, we kind of just crap out one big binary rather than a bunch of like per package ones. You can't call blocking calls into JavaScript. So if you register like an event handler in JavaScript like on click and you're expected to return true or false from it, you can't really. You can kind of kickstart things in Go, but the interaction between who's allowed to block and futures and stuff like that doesn't work exactly as sometimes people might expect. There are no threads. We use our own garbage collector rather than the one that doesn't exist in WebAssembly yet, but there's a proposal to maybe add one. So right now we have to ship our garbage collector. You can't have multiple threads because you can't do this really in JavaScript or WebAssembly either. So you can use Go routines, but it's kind of like the old school days where you ran Go max prox1 and it's all just kind of shoved onto one CPU. Next kind of big headline feature in Go 1.11 is module support, also known as kind of like the death of Go path. It's not dead yet, but it's like the writing's on the wall. And the release notes say the quickest way to use it is you just go to some place that's not in your Go path and start hacking there. There's these little Go mod files that you can write either by hand or you can use the tools to auto-write them for you. You can run go mod -init. This might have changed actually recently, but read the notes. And it will auto-convert your, if you used another system, it'll convert your dependencies from, what did it say? I don't know, three or four other systems. There's an environment variable where you can disable this if you want, but the default is if you're not in your Go path, Go modules are on, and if you are in your Go path, the modules are off. So if you want to experiment with different versions or different modes of this, you can. Other kind of neat small thing is in Godoc now, on the right side, it shows the version that things were introduced in. So this is a new function in the OS package to return like a user-specific cache directory that does the right thing for every operating system. For structs, or for fields of structs, it kind of shows it over on the right in a little comment. This is because I suck at UI, so that's what I came up with. If the struct field was always there from the same version of the type, then it's omitted. So it's only there if it's different. Performance, we always have this part about performance in the release notes, and we have this like hand-wavy thing that says, as always, things are probably better, but we don't really know, can't really say. It's because, it's kind of because we suck at measuring it and keeping charts over time, but it's also because some parts will get like 100x faster and some parts will get, maybe slower in some pathological cases. But in general, a lot of things are faster, especially if you're using a 64-bit ARM. A bunch of people, Cloudflare and Qualcomm and ARM, a whole bunch of people contributed to making ARM64 a lot faster. The compiler now does some things like recognize this idiom of deleting everything from a map, and except in some cases of like float 64 maps, it'll just clear the map instantly. The compiler has maybe a dozen or so of these sort of things it recognizes. But my favorite one is we had a prove pass in the compiler before that proved like things to itself, but it got really, really upgraded in Go 1.11. So I'm not going to walk through this, but it now keeps track of these relations. There's this bit mask of relations between two variables, whether things are less than or equal to or greater, and kind of starts off with all bits being set. It doesn't know anything. And then it keeps track of relations within domains, whether it's signed or unsigned, or booleans or pointers. And then for every like pair of variables, it like keeps track of what things it knows, relations between pairs, and what limits it knows for things. And it has this limit fact, and it makes this fact table. And then you could ask the fact table like what it knows, and it computes things transitively. And so then you can look at all the examples of things that it knows how to prove to itself in the test prove.go directory. And for instance, you can see like here, the first and third line will do runtime bounds checks. But the compiler won't add the runtime bounds checks for the rest because it's proved that it can't happen. Like for instance, here, the first 6 index, it doesn't know the length of the slice. But once you've already done it and didn't panic, it must be fine. And 5 is less than 6, so 5 is obviously fine. And it gets crazier. Like you can say, well, A is less than B, and A is greater than B. Therefore, A can't be A must be equal to B, so it can't be not equal to B. And so it can just like not compile that part at all. And this looks silly, but these things come up in real life, and there's hundreds of these things in the file. So you can go read the release notes and find whatever your favorite part is that's exciting to you. But section 2, I want to talk about what comes after Go 1.11. And I already told you the release cycle. So in 6 months, there'll be Go 1.12. Microsoft has Windows ready to run on like Raspberry Pis. So that'll be in 1.12. I'm not sure what else. 6 months after that, there'll be Go 1.13 in time for this conference next year. And that's it. Any questions? What? Go 2. Everyone wants to learn about Go 2. So there's this wiki page about Go 2 that has the status, and I created this wiki page just so people would have a place to look to see that there's no status. And maybe one day this will change, but it's in a very early planning stage. So I'm going to talk about what's kind of decided for Go 2 and what's undecided. So what is decided is that 10 years is probably like a good time for like the language to have been relatively boring, and it came out in November 2009. So a good release date for Go 2 might be November 2019. Maybe hand wave. This was Rob's observation. That maybe it's time to like start thinking about the language changes again. But not too many. As Russ said in his talk, maybe we can do 3 major changes and some like cleanup things, but it's not going to be a totally crazy new language. We don't want to destroy the Go 1 ecosystem. We don't want to pull a Python 3 or a Perl 6 where it's like we like split the community in half and kill network effects. So one of the design goals is not just that like Go 1 code can call Go 2 and but Go 2 can also call Go 1 code. So basically, we will not be killing any code that exists in the ecosystem. It'll always be usable. And anything that we add to the language isn't going to be because it's academically fun or whatever. It has to solve real problems. So there's this yearly survey that we've started doing a couple times now. And Russ kind of hacked up this word cloud of what people complain about using like little n-grams from the complaint text. I'll get back to that. But step 1 before we do Go 2 is really to like fix dependencies and package management and Go path and modules and vendor. It's a mess. It was the top complaint. Basically, everyone hates the current go get-u and Go path situation. So after that's done, let's say in a release or so. The plan is then Go 2 would pretty much depend on whatever that ends up being like, using Go modules in the Go 2 design, and maybe we'll modularize the standard library. So this is kind of one idea, definitely not decided, that maybe like things like net HTTP or other things in the standard library become shorthand for golang.org std net HTTP. And maybe when we ship Go 1.15 or 16 or 17, it comes with the exact same version number of the Golang std package. So you're getting the latest copy, and if you start a new project or you do update, you get the new stuff. But we can still fix bugs and add features without waiting for the 6-month release cycle. So that's something that's annoying right now, that if something is in the standard library, that means you don't get fixes for a long time, compared to if it's like in Golang X or something like that. So we want people to be able to get ahead of the Go releases without having to wait 6 months. In terms of what's undecided, we don't even know if we will call it Go 2. It may just be that like Go 1.15 or Go 1.16 adds new stuff. So yeah, maybe Go 2 will be 1.15 or 1.16. Maybe we'll call it Go 2 for marketing reasons, like Linux 3 and Linux 4. That like Linux 4, Linus just decided a new number was good. So generics. This was one of the other top things. Comes up all the time. We hear it a lot internally too. We cringe ourselves a lot at some of the code you have to write. A lot of people write code generators to do this stuff. So my guess is that any future Go release with new language features will probably not be called Go 2 without generics, because it's kind of crappy marketing to like make such a big splash with a new major version number with nothing really exciting to go along with it. That's just my guess. In terms of status, there is an issue. You can go read this. It's kind of chaos. There's a lot of people that think, just add generics. Come on, you guys are idiots. Like, here's some syntax. And the answer is never like designing a language by throwing out some snippets of syntax. There's problems go a lot deeper than that. But there is good stuff in there. It's just really hard to find. And there's this community summary discussion that's actually pretty good that says all the actual problems and what trade-offs to make. Ian on the Go team, who's responsible for GCC Go, he has written like 5 or 6 proposals about generics, and he's implemented some of them. And he generally like publishes them, rejects them himself the next day. Then he keeps writing new ones. Lately, he's been discussing generics more with Robert Griesemer on the Go team. So I imagine he will just keep thinking of these and implementing them and rejecting them, but I'm hoping that he gets somewhere good with it. The problem is we want in the standard library to have like type-safe data structures and algorithms and stuff, and we want good performance both at like runtime and compile time without lots of boxing and stuff like that. And we don't want to have these crazy error messages like C++. We don't want Turing-complete templates. We don't want crazy like action at a distance where you tweak this one part of your file and then 10 packages away you get some inscrutable error messages that you don't understand because it's wrapped in all this basic string, std string, comparator, blah, 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 blah. So we want just enough of generics to be like useful for some things, but to not be super, super powerful. So other top complaint is people don't like Go's error handling. This is like the one you see people complaining about on the internet, but there's other error problems in that a lot of the error values that people generate are pretty terrible. Fump.errf in particular is a good way to create a pretty crappy error message. I mean, it's fine error message, but it's a bad error value because you can't really ask a fump.erf error any questions. Like, are you temporary? I'm a string. So we would like it to be easier for people to do the right thing by default and keep track of where errors came from and their cause and maybe their stack trace. But at the same time, you want to be able to handle the errors properly, and you don't want a lot of like stutter and repetition and stuff in your caller code. It's also kind of annoying if you have a function that returns t, error. A lot of times people are tempted to return just t because they want to be able to chain a bunch of calls. And then, they shouldn't error that often, but if it does, maybe I'll just panic or log.fatal. Or you end up writing these things like regex must compile or template must compile. In the end, you have 2 versions of your thing, the one that panics and the one that doesn't panic, and that's kind of lame. So it'd be nice to just have like the t-error version, but like be able to do the chaining anyway, but also have good error handling. So a lot of people complain about errors. A lot of people have ideas. Probably need to do something about that. So my guess is that this is one of the top issues along with generics. So let's look into the crystal ball, look at some possible go-to outcomes. One outcome is go-to might be called Go 1.15. And Go path is kind of dead-ish. Maybe it's still there for some like compatibility thing, but everyone uses modules. And we start shipping latest versions of HTTP and elsewhere in golang.org/stud or something. And maybe we have some like error handling improvements, but there's like no generics. I don't know. Another possible outcome is we call Go2, and still calls Go 1 code. We don't have separate downloads. I don't think we're never going to have separate downloads for Go 1 versus Go 2. It'll just be you download the Go release, and it compiles all Go code that exists. And but if we call it Go 2, it's probably because it has generics. And we put a bunch of useful stuff in the standard library in terms of data structures and algorithms and stuff. Or we go even crazier and we do something like Rob's proposal to make int not overflow and to be an arbitrary precision number. But now you kind of like are breaking semantics of existing code in the while. So now we need to like annotate maybe at a package level, file level, I don't know, like which semantics you want to opt into. No plan exists for this. But then maybe you could do something different with generics. Maybe you could do different syntax or something that doesn't need to be backwards compatible with Go 1 code. Or we let Matt Klein take it over, and their working group calls it Go++. He was sad that he couldn't be here today. I'm not sure why he didn't come. He was like closing bugs or something instead, but he wanted to talk about Go++. You can find it on Twitter, except for you can't, because you can't search Twitter for Go++, but you can just read Twitter a lot, and you'll see a lot of discussion about Go++. Everything except for what it is. So in terms of the process for getting to Go 2, Russ gave a talk last year at GopherCon, and what's that? Okay, and he basically said, write a doc, say what works and doesn't work in Go, and there's this wiki page that has tons of stuff, like people, is it all complaining? There's probably some praise. Talking about contexts, and how context could be changed, and people talk about slices and things. It's a really long page. A lot of people have opinions about logging, and so the plan is to kind of read all these. And also, if you have an idea for what Go2 should do differently, write a proposal. It's really easy to write a proposal. You go to this URL and basically it says file a bug. And if your bug makes it past first level review of this isn't a dupe, then you could fill out a form. There's a template to fill out. So the process, I guess, because it doesn't exist really, is that we will read all the Go2 bugs. I know Ian and Robert have been doing that, closing a lot of the old ones and re-metadataing the other ones on GitHub. And then at some point, read all the experience reports and proposals and kind of consider what Go2 is. And got to consider them kind of as a whole rather than just ad hoc adding lots of language features. It all has to play together well, which is one of the things I like about Go. They didn't just, I'm not going to hate on other languages. Some languages add lots of things. And it's not obvious sometimes what idiomatic code looks like in those languages because you can write in 20 different styles. So I like Go that it's simple. So we got to keep that property. In terms of what's undecided in Go, in summary, everything. So if we have actual questions now, this is the actual end. But thank you.